Today we're going to discuss equivalent ratios and ratio tables. And previously we've talked about ratios before. Ratios are comparison of two different things. Please remember we can write a ratio with a colon, which is the two dots, as a fraction with a numerator and a denominator over a fraction bar, and then the word 2. So you can have a number and then the word 2 and then another number. It's just a way of comparing both items. So equivalent ratios are ratios that look different but show the same value as the original. So if we look at our example, we have 2/4, and it says that 2/4 is equal to 4/8. And we're comparing apples to oranges, and they gave us a nice little picture down here where we have 2 apples to 4 slices of orange. Now, if we look over here, it now takes that 2/4 and compares it to 4/8. If I draw a nice little line here, you can see that it's split into 2 groups that are the same as that original picture that they gave us of 2/4. Now, it says the ratio is the same, but there are 2 groups. It doubled. Because it doubled, that means times 2. If I look at my original fraction, which was the 2/4, if I multiply by 2 in the numerator and 2 in the denominator, I end up with that new fraction of 4/8. So an equivalent ratio is just another way of writing that exact same relationship. So there's 2 ways that you can find equivalent ratios, either by multiplying or dividing. You multiply if you want to have larger but equal ratios. So you're going to start with the fraction that they gave you, or you can simplify that fraction, and if you simplify the fraction 4/6, you can divide it by 2, and that will equal 2/3. So you can start with the original, or you can simplify, depending on the situation that you have. I'll show you both ways. So if you start with the 4, how can I get from 4 to 8? Well, I can multiply that by 2. And if I go from 6 to 12, that's also multiplying by 2. So as long as you keep the same factor that you're multiplying, which is that multiply by 2 piece, the same for the numerator and denominator, you're going to end up with that equivalent ratio. Now, I can prove that if I go back to this simplified fraction here. What can I multiply times 2 to get to 8? Well, I can multiply it times 4. And the same thing for the denominator. I can multiply it times 4. So that it actually shows that all of these, at least those first 3 that I wrote, are all equivalent. Now, I'm going to go back to the original one that they gave us, and I'm not going to worry so much about that 2/3 that I did. What could I do to get from 4 to 12? Well, I could multiply that one by 3, and the same thing for 6 to 18. So that shows that 12/18 is also equivalent to this 4/6 that's here. Keep going again. Is there something I can multiply times 4 to get to 16? There is. I can multiply by 4, and the same thing for the denominator. I can also multiply that by 4. So all of these fractions are equivalent, and you can even find a smaller one which is equivalent to 2/3. So you can multiply both the top and the bottom number of the original ratio by the same number. And you can multiply any numbers that they don't have to be in the same number sequence, but they must go from the smaller value to the larger value. And I apologize, that was my computer that flashed low battery, not yours. I did get my charger on. So, dividing, if you want smaller but equal ratios, you're going to divide because you want to make smaller numbers. So I'm going to take 12, and I can take 12 and I can divide it by 2 to get to 6, and the same thing for 16. I can divide 16 by 2 and get 8. Go back to that original. 12 divided by 4 would give me 3, and the same thing. 16 divided by 4 would give me 4. Now this is a special case where that middle fraction will also get me this 6/8. If I simplified it by 2, I could also get to this 3/4 over here. So sometimes it actually does work out that way. So I want you to try. I want you to use multiplication for number 1, and I want you to use division, and try to use, for the second one, and use the smaller factors like 2, 3, 4, 5 in order to complete those tables for me. So go ahead and take a pause and do 1 and 2. So for number 1, I'm going to multiply by 2. So 4 times 2 would be 8, and 5 times 2 is 10. And then the next one I'm going to multiply by 3, which will give me 12 and 15. And then the next one I'll multiply by 4, and I get 16 and 20. And if you need to draw in the arrows, please do draw in the arrows so that you don't make a mistake. If you did anything further down, multiplying by 5, multiplying by 6, as long as your numbers and your products are correct, then it's fine. For number 2, I'm going to divide this one by 2 here, because it works nicely, and I get 20 over 14. Now, if you tried to divide 40 by 3, I guarantee you ran into a problem, because 40 doesn't divide by 3 nicely. But I can skip that factor of 3 and just divide it by 4. Same thing, I can divide 28 by 4 and just move on. So I can get 10 over 7. Okay, looking at the next page. So equivalent ratios can be organized into a ratio table, which is what we've been talking about so far today. And a ratio table has columns that are filled with pairs of numbers that have the same value. They have the same relationship. So if I look at the table that they gave me, the ratios 1/3, 2/6, 3/9, and 5/15 are all equivalent since they all simplify down to a third. Or I could go forwards and say, okay, well that one was times 2, and this one's times 3, and this one was times 5. They just skipped that product of 4. So equivalent ratios express the same value. Again, they're the same thing over and over and over. You're just changing what you're multiplying that base ratio by. So to find equivalent ratios, we can multiply or divide just like we talked about on the previous page, but now we're going to use word problems. I know, creepy word problems, they're so terrifying. So to make yellow icing, you mix 6 drops of yellow food coloring with 1 drop of white food, or 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So I'm missing this number here. Okay, so use what you know about ratios. Whatever I do to the bottom, I'm going to have to do to the top. So I can multiply here by 5, and I have to do that to the top. So 6 times 5. So I'm left with 30 cups of white icing as my answer, because 6 times 5 is 30. If I look at example 2, in a recent year, Joey won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. That's outrageous. If he ate at a consistent rate, determine how many hot dogs he ate in 2 minutes. Now, in this particular problem, you don't necessarily need that middle pit stop box right here. But they're asking us to fill it in, so we can fill it in. First off, though, I'm going to jump to that 2. Because what can I divide by 12 to get to 2? Because I'm getting smaller, I have to divide. Well, I could divide it by 6. And the same thing, 66 divides by 6 nicely, so why not use it? I get 11. Now, I still have to go back and I have to figure out, well, what can I fill in this middle box with? Anything that's between 12 and 2. So, what could you divide 12 by to get a number in between 12 and 2? Well, we could get fancy and we could say, oh, we'll divide by 2 because 6 could go there. Or we can be even fancier and say, you know what? I have to figure out something that also divides 66. Well, 2 would work. But I want to get fancy and I'm going to say, okay, let's try 3. If I do 12 divided by 3, I get 4. 66 divided by 3 is 22. As long as you have one that's equivalent in there, that's fine. I just want to make you think a little bit. But we were looking for this answer right here, and he can eat 11 hot dogs. A lot of hot dogs in 2 minutes. Okay, so now let's practice creating a ratio table. So I'm going to do number 1 with you, and then I want you to do 2 and 3 on your own. A recipe calls for 5 cups of water for every cup of black beans. That's talking about 1 cup of black beans. How many cups of water should be used for 4 cups of black beans? That's what we're trying to get to. So to draw your table, just draw a rectangle, cut it in half because we're comparing 2 things. We need to put our label, what we know, and what we don't know. Name, known, unknown. So we have water versus the beans. I know that there are 5 cups of water for every 1 cup of beans. And it's asking how many cups, that's what we need to know, should be used for 4 cups of beans. So I want 4 to go here. This is our original ratio that they're giving us. That's what we're going to go to for right now because we can't simplify it anymore. What can we multiply times 1 to get to 4? Times 4. So I need to do the same thing to the numerator. 5 times 4 is 20. So I'm left with 20 cups for my answer. I want you to try number 2 and number 3. Use the same idea that I just did for number 1. Okay, so I drew my tables for number 2 and number 3, and I circled where you're going to find that number as your answer. So if we looked at number 2, I can take 16 and divide it by 4. And 12 divided by 4 would be 3. So I get 3 cups of sugar as the answer for that one. 10 to 1 needs to be division by 10. So 50 divided by 10 would be 5. So I'm left with 5 petals. And it's just really a name of labels, so make sure you're careful with labeling what pieces are coming from which word problem. All right, so the last page that we're going to look at is just still using more ratio tables practice. I'm going to do a few with you, and then you're going to do some on your own. So it says, using the table given, how many cookies could you make with 4 cups of flour? So I'm going to fill in the table. I'm going to put a 4 here. You go back to that original ratio. It's already simplified because it has a numerator of 1, so I'm not going to worry about simplifying it. I can easily get from 1 to 4. I can multiply it by 4, and then I'm going to do 30 times 4, which gives me 120. So I can make 120 cookies. Yum. All right, I'm going to jump down to number... actually, go ahead and do number 2 real quick on your own. So if I fill in that 90 here, I'm going to go back to that original, and I could say 30 times 3 is 90, so 1 times 3 gives me 3. So I need 3 cups in order of flour to make those cookies. Okay, let's look at number 3. Using the table given, at this rate, how many books would you buy with $5? Well, 5 is less than 10, so I'm going to put it here. Here's my original ratio. I'm going to deal with that. And I'm actually going backwards, so they're asking me to simplify this. How could I get from 10 to 5? Divide by 2. Divide by 2. And I get 3. So I get 3 books. Go ahead, pause, see if you can do number 4. So if I plug in the 9 here, I actually, for this one, can't go to this original ratio because 6 doesn't go into 9. I need to come down to this simplified one, and this is where I told you you might have to simplify in order to go forward. So if I take this simplified ratio of 3/5, I can take 3 times 3 is 9, and I can do 5 times 3 gives me 15. So at this rate, how much would it cost to buy 9 books? It's going to cost $15. So for some of these, you might have to simplify in order to get that simplified ratio and then move forward. And that's going to hold true in our next 4 examples. So if we look at number 5, Peter buys 12 bunches of bananas for $9. Use the ratio table to determine how much Peter will pay for 8 bunches of bananas. And it says, hint, fill in the gray boxes with the ratio that you are given. So we're given 12 bunches for $9. That's our ratio. But they want us to get down to 8 bunches. So if I simplify this fraction, 12 over 9, if I simplify that, it will become, because I can divide this by 3, and I can divide this by 3, I will get 4/3. Now I can multiply it to go forward into that 8 bunches. What could I do to 4 to get to 8? Well, I can multiply it by 2. Same thing here, multiply by 2 and I get 6. So it's going to cost me $6. On a hiking trip. Lavanya notices that she hikes about 12 kilometers every 4 hours. If she continues at this rate, use the ratio table to determine how many kilometers she would hike in 6 hours. Hint, fill in the gray boxes with the ratio you're given. So we are given 12 kilometers in 4 hours, and we want to make it to 6 hours. So think about it to yourself. Can you get from 4 to 6 as your denominator? It doesn't work. So you're actually going to have to do that simplifying one like we did before. Simplify and then multiply to go forward. So I need to simplify 12/4 down. And it will help if you simplify it down as far as it goes, but you don't necessarily have to. You could just simplify it down to 6/2 if you wanted to. You could just divide by 2. But if you wanted to divide it by 4, you could as well. The only reason I know I don't have to divide it the whole way down is because I know that 2 times something is 6. So 2 times 3 would give me 6, and 6 times 3 gives me 18. So it'll be 18 kilometers. So simplify to multiply and move forward. Number 7, containers of yogurt are on sale for $8. Use the ratio table to find the cost of 18 containers of yogurt. So this is the yogurt, and this is the cost. And they're telling me I have yogurt on sale for 12 for $8. So I could fill it in here if I wanted to, 12 for $8. Use the ratio table to find the cost for 18 containers. So I want to get to 18 by the end of this. And if you wanted to fill this into the middle, that's not wrong. Either way, I'm not picky. Now, 12 can't go into 18. So I'm going to have to do that simplify and multiply to go forward. So I need to simplify this. And if I simplify this by 2, I get 6. And if I divide by 2, I get 4. Is 6 a factor of 18? It is. So I simplified it down, and now I can multiply to move forward. Times 3, times 3, and that gives me 12. So it's $12. Bora paid $10 for 45 tokens to play an arcade game. Use the ratio table to find how many tokens he would receive for $16. So this is tokens to cost. It's 10 to 45. Oops, backwards. Because the tokens was 45 to $10. And I want to get to $16. So I want you to try this one all by yourself. So this is one where you're going to have to divide and then multiply to go forward. I can divide by 5 here, and I get 9/2, and then I can take the 2 and multiply it by 8. 9 and multiply it times 8, and I get to 72 tokens. Okay, if you're having any problems, make sure you go and see your teacher. Other than that, have a wonderful day.